All right, first of all, can people hear me if I speak without a microphone? Is that going to work? Yes? Okay. Let me know if it's a problem. So in this talk, what I want to do is talk about the problem of demarcation as it arises in philosophy of science. And it's related to a little bit to the last talk in talking about skepticism, what we should believe and shouldn't believe, but in particular, what counts as science and what doesn't count as science. What I want to do is present this problem, give an overview of some of the more influential attempts at solving this problem, and then provide reasons for thinking that any demarcation criteria should be contextualized in current science, and sort of end with some thoughts about how to argue about what's science and what's not science, or what's science, what's pseudoscience. So first, the problem of demarcation. Demarcation is different than simply thinking about how science differs from non-sciences, such as how science differs from art, for example. It's really about the difference between a genuine science and a pseudoscience. And it arises just, there's been many claims of certain kinds of movements where individuals claim that their teachings are scientific, and then others reject these and say that they're pseudoscience. So, let's say a little more precisely what is pseudoscience, how we should understand what a pseudoscience is. Generally, it's an activity or teaching that is not scientific, but has major proponents behind it who claim that it should be considered scientific or that it is scientific. Some examples, common examples, creationism, astrology, ESP, phrenology, alchemy, and we can make a much longer list. And partly what goes on that list will depend a little bit on who's being skeptical and who's not. Okay. So what, I think generally, when you ask people about demarcating science and pseudoscience, I think most people will probably bring up something like falsification. They'll bring up and they'll say that it's not a science, it's not falsifiable, or something like this. And this comes classically from Karl Popper, 20th century philosopher of science, who is interested in what distinguishes science from pseudoscience, and he sort of made this the problem for much of his research. He describes becoming interested in this through his youth. He was interested in many theories that were popular in the early part of the 20th century, including Freudian psychoanalysis, individual psychology, Marxist theories of history, and especially Einstein's theory of general relativity. He eventually became disenchanted with these theories in psychology, Freudian psychoanalysis, and also Marxist theories of history. And he wondered what distinguishes what Einstein's doing, he thought, from what's happening in these other disciplines. He was also bothered by debates that were going on in science at the time. At the time, philosophers of science. Philosophers of science at the time were interested in distinguishing science from metaphysics. And they proposed a verificationist schema for this, where they thought the facts of science, or the theories of science, could be verified. Popper was deeply bothered by this. He didn't think you could verify any of the claims of science. He thought you could only show that they haven't been falsified. But he also thought that they could all in principle be falsified, and this is what he thought was key to science. So he thought science progresses by testing theories and abandoning those theories that fail tests and upholding those theories that pass these tests. So the theories that he was interested in are sort of very classic examples of scientific change. So quickly, the theory of phlogiston was a popular theory of combustion in the 18th century chemistry. The basic idea is if you have a metal and you burn a metal, you light it on fire, what's happening there is the metal is made out of this earthy calx and in combination with phlogiston, some sort of fiery substance. And when you burn it, the phlogiston goes away and leaves the calx. It was discovered, though, that the calx is heavier than the metal. And so some theorists adjusted phlogiston theory by saying that phlogiston must have negative weight. So when you light it, the negative weight goes away and the substance left over is heavier. Lavoisier, a French chemist, through some careful experiments, was able to show that there's a better theory. So one thing that he did was had combustion in an enclosed chamber and showed that there's no weight loss. If you seal everything, no weight's lost. And then he could show that the weight gain of the calx is exactly equal to the weight loss of the gas. And so he hypothesized instead of phlogiston, what's happening is that there's a gas, which he called oxygen, that combines with the metal, and this explains the weight gain of the calx. And so combustion is explained by the combination of oxygen with the metal in this case. So it looks like he gave a test to the phlogiston theory, falsified it, and then moved on to a better theory. Another example that Popper was especially interested in was with general relativity. General relativity, unlike Newtonian physics, predicts that light will bend when it goes through a strong gravitational field. This could be tested during an eclipse because you could check where the sun is, that gives you a strong gravitational field. And you could have a star that's very close to the sun in the sky, and you can make a prediction on where it should appear. Of course, you can only look at things close to the sun during an eclipse, so that's why you need the eclipse. This test was made in 1919 by Eddington and others, and it turns out Einstein's predictions were right. You would never be able to predict this with Newtonian physics, so it looked like Newtonian physics was falsified. So this was how science changes, and he thought this was sort of a key component of science was this notion of falsification. Pseudoscience, on the other hand, is something that's either unfalsifiable, it doesn't make any predictions that you could go out and test, or it's something that's been falsified, but people just maintain that it's true. So, according to Popper, if you maintain phlogiston theory today, in the face of all of these experiments, he would say you're practicing a pseudoscience. And then he thought back to the other fields that he was interested in, Marxist theories of history, Freudian psychoanalysis, individual psychology, and he argued that these were too vague to be falsifiable. He was bothered, for example, in individual psychology, he asked practitioners about certain cases where they hadn't done any questioning or anything, but they already knew the answer about why somebody was suffering in a certain way. They already had a clear explanation for it, and he was very bothered by this because it seemed that they didn't even want to check further. They already had it all worked out. It seemed like there was nothing you could give them that would make them question their theory. So he thought that they were unfalsifiable. Okay. Popper's criterion then of falsifiability has been the subject of lots of controversy. And the problem is this. Well, there are a couple of problems. One problem is that some genuine science ends up looking like pseudoscience. We get to theories that are apparently falsified, yet scientists hold on to them all the time. And this is much more common than Popper realized. So even in Newtonian's Principia, in his greatest work, he knows that he can't explain certain things that he should be able to explain, and yet it doesn't bother him at all. So in his first book of the Principia, he calculates the orbit of the moon, and he knows he's got it wrong. He checks with the data; it's wrong. He's off. He doesn't know why, but he doesn't think for a moment that this is the end of his theory. He doesn't stop there. He just keeps working. So right in the Newton's Principia, you might read it and think that this is already falsified. Why does it still count as science? Well, nobody really doubts Newtonian physics as a case of science. Another famous example from Newton that comes later is the perihelion of Mercury. That Mercury's perihelion moves at a rate that's faster than you would predict with Newtonian physics. A French mathematician, Leverrier, tried to accounts for this by proposing an auxiliary hypothesis that there's another planet between Mercury and the Sun, he called Vulcan, and that if we just point our telescopes in the right spots where he's done the calculations, we'll find this planet, and that'll explain the motion of Mercury. This works very well for finding Neptune. This is how Neptune is discovered by the same mathematician's calculations. But we've looked and looked, and there's no Vulcan. Nobody's been able to find it. So it looks like there's another example of an anomaly the Newtonian theory can't explain, and yet, while people are interested in this problem, nobody thinks we should just throw Newtonian theory away. Right? So it looks like we've got a science that, on the face of it, is falsified, and yet we still count it as a science. Okay, another problem would be this. Certain aspects of genuine sciences are unfalsifiable. I keep picking on Newton, but it's just to be a good example. So, Newton's first law of motion: an object in motion will stay in motion in a straight line at constant velocity unless it's acted upon by an outside force. This is one of the fundamental laws of Newtonian physics. But is it really testable? Well, think about it. Has anybody ever seen an object move in a straight line indefinitely without any change in its motion? Well, no, nobody has. But he's got this ceteris paribus clause, unless acted upon by an outside force. So that any time that you see an object that's not moving in a straight line indefinitely, it's just explained by other forces. Right? And this is such a part of physics that it's hard for us to think about how crazy it might sound to somebody who's being skeptical, or how crazy it might have sounded to people first reading Newton or Galileo, who really first formulates this. But in astrology, if we say something like, the reason this person has a bad attitude is because Mars was rising in their sign, and then if it turns out Mars was rising in their sign, they have a good attitude, we just say, well, there are other forces that were active, right? Just explained by these other forces. So there's a sense in which even Newton's first law, a very clear piece of science, is unfalsifiable. Okay. So, it seems that some genuine science is falsified, yet we still believe it. We treat the conflicts as mere anomalies, things that we can test later. And we also maintain scientific beliefs that are apparently unfalsifiable. Or at least we think of simple tests. We'd be perfectly willing to hold up the belief in the face of those tests. Okay. All right. Another problem for falsification. So we've seen that it misclassifies certain sciences, but it also might misclassify certain pseudosciences. So astrologers can make predictions that are testable. I gave an example just a minute ago of Mars rising in your sign when you're born, and that explains your personality. Well, we can test it in some sense. And if we look just at our horoscopes, they're testable, right? They make clear predictions. So this one says, a semi-truck full of dimes will hurl down your street and crash into your house, leaving you with no dreams to achieve in life. A very clear prediction, something that's certainly testable. So if you're a Pisces, a couple of weeks ago, you know whether this is true or not. If the semi-truck didn't crash into your house, then probably there was something else happening. Or Leo, due to an unusual coincidence, your fortune this week is the same as for November 19th, 2005. The bartender will even use the same act. I am a Leo, and I know this has been falsified. The axe was clearly different. And I chose these from the greatest astrological sources I could find. But more seriously, there's no reason why an astrological prediction can't be falsifiable in any case. Similarly, Marxist theories of history do make predictions. They make predictions about where revolutions are going to occur first. These are testable. Freudian psychoanalysts can make predictions about people's behaviors. These can be testable. There's no reason for them not to be able to. So on the face of it, falsification sort of simply applied doesn't look like it's going to work, at least by itself, for demarcating science and pseudoscience. What we need to do is think about where falsification works, where it doesn't work. So one person who was interested in this was Thomas Kuhn, who saw himself as Popper's arch nemesis, though really I think that they're more alike than neither of them like to admit. But he argued that hypothesis testing was a common part of what he calls normal science, but that testing of theories, the kind of falsification that Popper talks about, is something that only occurs during revolutionary science. In his view, what characterizes science is puzzle solving. Current theory is accepted, it's not tested. We don't go and test our deepest theories. We go and test various little problems, and we use those theories as background assumptions when we're making these tests. So there is a bit of falsification that occurs in the kind of Kuhnian system in solving these puzzles. There's small little tests. It's just the tests aren't of our core theories. And pseudoscience, according to Kuhn, lacks this puzzle-solving nature. Astrologers, he thinks, aren't going out and working on various puzzles that arise and trying to solve these kinds of puzzles. They have theories, but no new knowledge is being produced. They're not progressive. And this is what he thinks is the mark of a pseudoscience. Okay, well, there are problems for this way of thinking about pseudoscience as well. Puzzle solving can be part of pseudosciences. There's no reason for it not to be. Alchemy is a good example of this. Though alchemists are interested in transmutation of metals, they're going out and they're working out on all kinds of problems, working out their notebooks and figuring out various ways that chemical change is occurring. They are producing knowledge, and it was progressive. And yet, we usually think of it as a pseudoscience. It's also possible, you might think in exact sciences, that puzzles sort of stop. And there's no more problems to be solved within a small subdiscipline. And those might just be then used later in other parts of sciences. So it's not even clear that puzzle solving is a part of all parts of science. Okay. Now, Kuhn and Popper are probably the two sort of major thinkers to sort of propose these sort of general approaches to the problem of demarcation. And various other people have followed, and they sort of fall into one or the other camp. Kuhn really emphasizes progress and scientific change. Popper emphasizes falsification. And so these other attempts really sort of follow in these footsteps. They kind of fall into one camp or the other for the most part. Okay, so emphasizing progress, not necessarily puzzle solving, but some sort of interest in progress. The knowledge is being generated continuously, they say, as a mark of science, and that pseudoscience lacks this quality. Or they try to improve on Popper's falsification. So Lakatos, you can see, is sort of taking Kuhn and Popper and sort of trying to bring them together and creating a better system of demarcation. What we see, I think, happening most often today, for example, in the Dover trial about intelligent design, creationism, as you see philosophers and scientists providing a kind of list of criteria, some combination of which is used to demarcate, they'll usually say, most science from pseudoscience. So people like Michael Bruce will give a list, and they won't claim that this will work for all science and all pseudoscience, but they'll say this gives us a kind of ballpark description of what science is and a ballpark description of what pseudoscience is, and then argue that intelligent design very, very clearly falls into the side of pseudoscience. Okay, so now what I want to do is think about demarcation, and think about history, and think about the nature of science a little bit, and try to propose a way to kind of work through the problem of demarcation. It's not that I think all of these attempts are bad or wrong, but that we can improve on them by thinking about context and the nature of science a little bit. So one of the difficulties that we've seen comes from the history of science. We make a claim about demarcation, and then we find all of these counterexamples from the history of science. Thank you. The problem with this is that also we find many of these so-called pseudosciences were once part of accepted science. So alchemy was practiced by Sir Isaac Newton, Robert Boyle. It was chemistry. And it was, I think, for that time, we might think, very scientific. So this makes whether something is pseudoscience or not, we might wonder whether it's contextual, whether it depends a bit on what the scientific community is doing more commonly. And some philosophers, current philosophers, explicitly recognize this and explicitly claim that their demarcation criteria are relative to current science. And I think that's a positive step. Okay. When we might think about this, we look back at the history of science, we realize that the aims and values of scientists have changed over time. What gets accepted as a good method in science, or what gets accepted as the right kind of ontology for science, changes with the way the scientific community changes. So an example of this, we go all the way back to Aristotle. He thought using teleological arguments to make sense of order in nature was just the best way to explain various patterns in nature. Modern scientists mostly shun teleology, and they at least shun Aristotelian notions of teleology. Seeking evidence of the supernatural or properties of the supernatural was common in scientific writings. We go back to Newton again. He's got all kinds of claims about the nature of God based on his ideas about universal gravitation. And this was something that we accepted. People wouldn't be surprised to see claims about God being made in scientific writings. Today, you won't find anything like that in a scientific journal. You won't find a sort of conclusion about the nature of God based on what somebody discovered about mitochondrial DNA, for example. And it's really only in the 19th century that we start thinking of scientific knowledge as something that's revisable, instead of sort of, here's the truth and now we've got it. These are all modern developments in the sciences. So this suggests that when we're thinking about demarcation, we need to think about what context we're dealing with. We need to think about various kinds of values that the scientific community holds when we're trying to say whether something's science or pseudoscience. Okay, so science is a social activity. It is something that we produce. The goals and the values and the methods of the scientific community change over time. And I might add to that the ontology, what's accepted, what kinds of things are accepted in science. And the criteria for demarcating science from pseudoscience is also going to change throughout time, throughout history. So, philosophers and scientists, I think, would be better off trying to discover the current goals and aims of scientists when they're trying to decide whether a particular doctrine is pseudoscientific or not. And the solution for the demarcation problem, I think, shouldn't be a one-size-fits-all kind of criterion. I think the mistake that Popper and Kuhn and others have made was that they thought they could give us a kind of monolithic set of criteria that would just demarcate science from pseudoscience for all time, for all possible science. This seems to me like it's never going to work if we go that route. Okay. Also, we might even wonder if the goals and methods in question that demarcate science are going to might even vary from discipline to discipline. Or whether the science itself is in infancy, or if it's a rather mature science. If the experimenter in question is doing exploratory experimentation, or if he's testing theories and testing hypotheses. All of these things are going to affect whether we should judge something as a science or pseudoscience. Okay, so a lesson for philosophers here is we should worry, I think, less about timeless criteria and really try to see if the criteria we come up with reflect what scientists are actually doing and what they actually care about. Okay, so now I want to turn to an example of a current criterion that's been proposed that I think is a good one, though it should be understood in our current context in the sciences. So methodological naturalism is the view that all phenomena should be explained in terms of natural causes. This is clearly a value of much current science, and it's clearly not one if we go back to the 18th century, for example. But for today, I think this is mostly uncontroversial. So Pennock, who was one of the expert witnesses at the Dover trial, argues that methodological naturalism is assumed by most scientists, and that we can use this very often as one way to demarcate science from pseudoscience. It won't be the only way to demarcate science from pseudoscience. There'll be plenty of pseudosciences that might be acceptable by methodological naturalism. But it's one way to look for pseudosciences. Some philosophers have argued against this. Montagn's argued against this. And usually when they argue against it, Montaigne, Dembski, and others, they come up with these implausible scenarios showing that it would be rational in certain cases for scientists to give up on methodological naturalism. So one example that Montaigne brings up is imagine that there's a pulsar at the edge of the universe, and it starts blinking in Morse code various messages to us. We don't have any way to explain that with our current science. It would look like anything that could do that must be pretty powerful. And it might be rational then to think that God's manipulating pulsars at the edge of the universe and he uses Morse code. So this, he thinks, would be a case where it would be rational to give up on methodological naturalism. But I think this is sort of ridiculous. Methodological naturalism is being pulled out of what scientists are currently practicing. What are scientists really concerned about? They're concerned about explaining actual observations. Making claims about what scientists would do in some crazy universe is probably not a good way to make a claim about demarcation. Right? It might be that we give up on science in a crazy universe. If the universe isn't orderly, then science might be impossible. So what we need is to think about actual observations and the kinds of predictions that scientists are curious about. If something pops up like this, then maybe it will be rational to give up on it, but that doesn't mean that it's rational to give up on that methodological naturalism right now. So the mistake, again, is to try to give a demarcation criteria that's sort of one-size-fits-all for all science and all possible universes, all possible observations. Okay, so we don't need to require that demarcation apply to all possible experiences. We only need it to work within the sciences that we're dealing with, the kinds of experiments that scientists are doing with this. So we need to contextualize demarcation criteria to current science. And I think if we think of the methodological naturalism as contextualized to current science, then it can be used to demarcate some science from some pseudoscience. Okay. So maybe not all. All right. So let's think a little bit about what it means to claim that something is science, and think about then how we can use this to engage people who are trying to argue that some discipline or some teaching should be part of the sciences. To claim that one is part of the scientific community is to claim that one's got certain kinds of goals, certain kinds of methods, certain kinds of values that are shared by this community. So if I claim that something is science, I'm claiming that the study of it partakes in the same kinds of methods, values, and goals as this community that I want it to be a part of. So for example, to claim that intelligent design is part of biology or should be part of biology is to claim that the practitioners of intelligent design have the same kind of goals, values, and interests that the community of biologists has. And I think then to show that intelligent design is a pseudoscience, all we need to do is show that they really don't have the same kinds of values, goals, and interests in mind that the biologists have. So I think that the issue is what kind of community are they really a part of? Are they trying to really become part of this community, or are they trying to do something else? And I think that's the key issue of whether a particular science or pseudoscience is pseudoscientific or not. That's all.
Great. Any questions?
Regarding certain theories that try to explain the origin of the universe, would you say that things like string theory or multiverse theory, in your opinion, would those qualify as pseudoscience or attendance?
Good. I was glad you asked that question. So, on the one hand, I'm not qualified to say whether string theory is a science or a pseudoscience. But let's think about it a little bit. So I talked about how it's possible that the criteria for whether something's a science or pseudoscience might even depend on the kind of discipline that we're interested in. So I've heard people say that string theory is a pseudoscience because they say that it's the experiments that we tested are impossible to perform, or they would require the energy of the solar system or something like this. I don't know if that's true, but maybe it's true. But we might wonder if fundamental physics has the same kind of criteria as, say, evolutionary biology. We might wonder whether being able to test it directly through experiments is as important to fundamental physics as it is to other areas. And I think that that's a place where my impression is that that's something that some fundamental physicists disagree about. We might wonder that we can have a great mathematical theory and be in a spot where testing is very difficult. We might then fall back on things like simplicity and other values. So I guess to answer your question, I don't know if it's a science or a pseudoscience, but I think it's an interesting example because how we evaluate it is going to depend on the goals of fundamental physics and where fundamental physicists think we need to go. But yeah, so it's a tricky question, but I think ultimately it's going to have to be decided by the physicists themselves, and it's going to depend on what they think is most important. Yeah.
Well, first of all, I thought the planet Vulcan had been discovered with people with 20 years, but anyway, that's fine. I think when you say astrology can make, even though we consider it a pseudoscience, can make precise predictions, isn't it? The very survival of astrology depends on making imprecise predictions. Because I don't look at the horoscope, but every once in a while I glance at the one for Scorpio, which is what I am. It's so vague that almost anything that can happen to me I can interpret it as fitting into that projection.
Right.
And so it thrives on the fact that people can say, oh, well, it's true, but yet it's not really precisely falsifiable.
Right. I think that's true. I think it's certainly true of our horoscopes that we see in the newspapers, except for The Onion, where I got. I've been reading the wrong newspaper. This is part of the problem. But if we look back, you might wonder, going back to Kepler, say, and looking at the things he's doing with astrology, and whether it's all vague predictions or whether it's just more of this grand picture of the universe. That he's explaining the order of the universe by appeal to various astrological kinds of things. And astrology, what we usually see from astrology is just these horoscopes, and of course those are vague, and I think falsifiability works very well in those cases. But we might wonder about, we dig through astrology works, particularly historical works, Ptolemy, Kepler, and others, to see if they do make precise predictions, or if they can make precise predictions. And I suspect that we'll find instances where they do, and they might end up being wrong. But notice they've got a nice system for dealing with how they can be wrong. They can always say there's so many forces that it's not going to work out, right? I think you and then.
I mean, falsifiability is an important part of theories, but I couldn't help but think about replicability of theories as being an important part of the a scientific pursuit. And so a number of those examples, even with Newton's first law, that's something that anybody anywhere could do the same thing and get the same result. And it doesn't necessarily mean that, it's a falsifiable theory because we don't have, access to the conditions. But, replicability is something that I think should be thrown into the discussion.
Yeah, so most of I said some of the more recent theorists often give a kind of list. Probably all of those lists will include replicability. Bruce certainly includes it in his list. People like Popper are bothered by it because they don't think that induction is worth anything. They don't think you can verify these things. Now, that's clearly a controversial claim. Most people probably disagree with Popper on that. But that's why, for example, why he emphasizes falsifiability and not replicability. But you're right. I think that most current scientists, probably in most disciplines, would uphold replicability. Jim.
Back to the issue of astrology. I think there are a number of factors that perhaps go into both the popularity among the population for astrology and the lack of interest in the scientific community. One is that, as a matter of fact, astrologers, if you start really looking at it, ignore what it says in the newspapers. That's not much. You'll find that there are people who are trying to deal with where there is accuracy and where there isn't accuracy, and there has been statistical studies. For example, I forget his name, a Frenchman, who showed that there were some correlations that were not dismissible by simply statistical anomalies. Some of them conformed to traditional astrology, some of them didn't, interestingly. But one of the things I think that contributes to the popularity of astrology is that it actually connects with people's lives. You can tell me that Jupiter is in a particular position astronomically, and that's informative. But saying that Jupiter is in a position that has this possible impact on your life makes it a more relevant issue. And again, it's going to depend on how seriously you get into it. If you just consult the newspapers, that's not going to be much. But there are ways of getting into it that provide much more insight than generally given credit for.
Right. Yeah, I think if you ask most people who read their horoscope if they really believe in astrology, they're going to say no,
just for fun or something like this, that they find it entertaining to read these things. The way it was used anyway, in the sciences, going back to people like Newton and Galileo were very worried about astrology. They were, some people think that the reason Galileo rejected the idea that the moon had an effect on the tides was because he didn't want to admit of any kind of spooky forces from astrology. And this might also be partly why he and Kepler didn't get along so well, because Kepler was very much into astrology. But I think you're right that what attracts people to it is that it makes parts of the universe somehow matter for their lives, which they wouldn't think matter otherwise. And that is, I think, appealing to a lot of people. Absolutely. Joe?
When we're using methodological naturalism as a criteria, how does umbrellaology fall into that?
Just so everybody knows, not everybody is in my philosophy of science class, so not everybody knows what umbrellaology is. But imagine you've got a guy who's been studying the use of umbrellas and has been writing down all kinds of statistics and has been able to formulate certain testable laws, like the use of umbrellas is more common on rainy days than on non-rainy days, and that women are more likely to have colorful umbrellas than men, or something like this. I think in the case of umbrellaology, if it's not a science, if it's a pseudoscience, it's only because there might be alternative explanations for these behaviors that are better than these sort of laws that have been generated by the umbrellaologist. It's not because of methodological naturalism, because the umbrellaologist need not specify any supernatural causes. But I think it's this issue about community again, and whether the umbrellaologist is really engaging the community, their methods, their system of investigation. So I think the umbrellaologist would do better trying to understand the umbrella-related behavior by relating it to economics or to culture or to psychology or these other kinds of things, rather than to try to say I've got a new science of umbrellaology.
Using things to predict makes a difference too, and that's what I think you're thinking when you're talking about Newton. He predicted an awful lot of things work like they do, or at least for all practical purposes that we use. Right.
Yeah, there's a sense that nothing succeeds like success, and Newton's theory was extremely successful, right? And yeah, his publication, Principia, this is why people were writing poetry to Newton. That he saw all of the major problems of physics of the day. It looked like we had a foundation that all science could just grow from. He suggested that was the case. Philosophers would then try to build foundations, metaphysical foundations, to try to show that it was necessary that Newton was right. Yeah, so absolutely prediction, being able to predict things precisely is something that's clearly a property of science.
And you can't do that with the umbrella. Can you? Whether I'm going to use one on a rainy day or what color it's going to be.
No, but you're getting sort of a statistical explanation.
Oh, that's what most people do, yeah. Okay. But you still,
right.
You still don't know.
Right, yeah, I would just point out that we use statistical explanations in the real science as well. We have a kind of broad, here's the general behavior that you're going to expect to see. Even thinking in ecology, if we're thinking about herding behavior, we can talk about where the herd's going to go and make pretty good predictions about that we might not be able to do with the individual.
And it's some from experience. I was a math major and a physical science associated with sciences for quite a while. And they kind of thought, there was a difference between hard sciences and soft sciences. And, it's getting more scientific for the soft ones. It's more respectable and more whatever.
Yeah, there's an issue about where science is evidence. Sometimes the debates that occur in sciences are occurring precisely because we don't have enough information information yet, and the science is just going to have to grow. But the fact that there's debate there isn't always a sign that the science is that it's pseudoscience. It's just that often there's a lot of confusion.
I also lived through the stage where when I was growing up, it was called history and geography and social studies. And then after Sputnik, everybody wanted to be a scientist.
Right. Well, I don't blame them.
That's all the time we have for Q&A, so let's give another round of applause for Dr. Goodrich.